The next we are going to see about shift counter. Shift counter is also known as Johnson or twisted ring counter. It can also be asked as Johnson counter or twisted ring counter. Okay, so the first point is, in a Johnson counter or twisted ring counter, the Q output of each stage of flip flop is connected to the D input of the next stage. Okay, the Q output of each stage is connected to the D input of the next stage, and the complement output Q bar of the last stage is fed back to the input of the first stage. Okay, so the next point is, the last stage Q bar D is fed back to the first stage input DA. Initially, the register is cleared. Therefore, QA, QB, QC, QD equal to 0, 0, 0, 0. Since QD equal to 0, Q bar D equal to 1, because it is complementary, right? So, if it becomes 0, it becomes 1. If it becomes 1, it becomes 0. The next is, DA will be 1 when the first clock pulse is triggered, QA becomes 1 and the remaining outputs are 0. When the second clock pulse is triggered, QA and QB both becomes 1 and the remaining outputs are 0. So, the answer is 1, 1, 0, 0. The change of state is shown in the following table. After 8 states, the same sequence gets repeated. So, it will be repeating. Okay. So, truth table of 4-bit ring counter is, the clock pulse we are taking 0 to 7. There are 4 bits QA, QB, QC, QD. So, we are giving the values. First one is 1, 0, 0, 0. No, for the 0 clock pulse, all the bits are 0. The first clock pulse is 1, 0, 0, 0. The second is 1, 1, 0, 0. Right. The third is also 1, 1, 1, 0. In the fourth, all the bits become 1, and from the 0, it will be like reversing. 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1. Okay, this is the truth table of 4-bit ring counter. The Johnson counter or twisted ring counter. Okay. We have logic diagram and timing diagram for this ring counter. The logic diagram is, we are taking 4 boxes A, B, C, D. It has DA input, QA output and a complementary Q bar A. DB, QB, Q bar B, DC, QC, Q bar C and DD, QD, Q bar D. Okay, all the clock pulses are connected, and in the line we have seen, right, the D input of the next stage and the complementary output Q bar of the last stage is the complementary output Q bar of the last stage is fed back to the input of first stage. So, that is what happening. The first stage input is connected to the complementary of the last stage output. The complementary output. Okay. So, DA is connected to complementary Q bar D, and the line goes between QA to DB. So, the output to input, QC to DD is all QA, QB, QC, QD. Okay, these are the outputs. So, this is the logic diagram. So, the next is timing diagram. We are taking 8 bits. So, the clock line has 8 bits. QA is, first is slower, the next 4 bits are higher. Right, 0 and 1, 2, 3, 4 are the higher states. So, we are giving this. First one is 0 and the last 4 is higher state. The next becomes lower state. Same goes to QB. From where it has higher state, it has higher state from 2. to 5. So we are drawing the line from 2 to 6. So this is 2, 3, 4, 5. This is 0, 1, 2, 3, 4, 5, 6, 7. Like this we are taking. Okay, so because 0 to 7 only we have clock pulses. So it should be count as 0, 1, 2, 3, 4, 5, 6, 7. But in diagram we are starting from 1 just for the show. Okay. QC is from where it become higher state. QC become higher state from 3 to 6. So we are drawing from 3 to 6. All the states are lower state, from 3 to 6 only higher state. Same goes to QD. Okay. So this is the timing diagram of 4-bit twisted or Johnson ring counter. Thanks for watching. Bye.